All right, here we're looking at section 6.2, and we're really looking at this number e that's our natural base. So first we want to start with our learning targets, and that we just have one for today. I can define, use, and graph the natural base e. So on your next clean sheet of paper, here's where we're going to start. And I'm going to go ahead and label my notebook just so I know exactly what I'm talking about. This is section 6.2. So the first thing we're going to do is we're going to take a little bit of notes without any paper that I've given you, because first we have to define what E is. So E is a number. So E is an irrational number, and remember that irrational numbers are decimals that never end and never repeat. So it's just this number that keeps going and going and going and going and going. But here's what E represents. So as x approaches, and that's what we kind of say as x approaches, so we use a little arrow. So a positive infinity, here's what I have. I have 1 plus 1 over x to the x equals e. Okay, so it approaches this value is really what we're going to be looking at. So if you were to pick some x values that were getting bigger and bigger and bigger and bigger and bigger increasingly, here, and we're going to turn this into an arrow because it approaches e, you will see that your numbers start getting closer and closer and closer to this number, and that's what we're really looking at. So there's kind of our definition. So really what you're going to need now is this green little piece of paper, and we're not going to fold it, we're just going to glue it in so we can take some notes on it and actually have a place to put our graphs. So go ahead and take a minute, get this glued into your notebook on this page, and we'll go from there, and we'll actually start filling in our notes here. Okay, so now we're looking at natural base functions. So that natural base is e. That's really what we're talking about, is that e. So our function, our natural base function, takes this form, y equals a e to the rx. Okay, so these are just kind of the values that we're looking at. So here I know that a is going to be greater than 0, and r is also going to be greater than 0. So when those two things happen, when they're both greater than 0, I know that I'm going to have exponential growth, which we talked a little bit about in that last section. So refer back to that if you're stuck on what exponential growth is. So what does that look like? Again, so here we're going to actually just graph a little quick drawing of this. So growth. I know that in the general form, so this is going to just be y equals e to the x. Okay, so just our kind of parent function. My graph crosses the y-axis at 1, and when x is 1, when this value, my exponent is 1, that's where I cross through my e value, which is 2.718, da 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 da, on and on and on. So I'm going to go ahead and at 1 and 2 point something-ish there. And it's exponential growth. So remember, I do have an asymptote here, which is my x-axis. Okay, so there's my exponential growth. So now what happens if a is greater than 0 but r is less than 0? So my r now is negative. So that's going to be where I have exponential decay. So we're going to graph here y equals e to the negative x. Okay, so again I can plug in different x values. But if I plug in 0, I know that I'm going to get 1 because anything to the 0 power is 1. And if I plug in 1, I'm going to have 1 divided by my e value, which is 0.368 da 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 da. So here's what my graph looks like of y equals e to the negative x. So now what we can use this information to help us is now we can do those transformations. Now we can add an a value in and see what happens. We can tweak our r value a little bit and see what happens. So really what you're going to be doing is using this to kind of just help you start. And then we do our transformations. Make sure you're using Desmos to help you see, okay, so what does A do? Remember, A is always our stretch and shrink. What does R do? How does that change what my function looks like from these parent functions? Okay. The other thing we're going to talk about is in that last section we looked at compound interest. So there's another type of compound interest that we need to know about, and there's another magical word in here. So here's this part. It's continuously compounded interest. Okay, so in that last section we talked about compounded interest, and we looked at the formula for that. Well, in that formula we had to be told how often our interest was compounded. Well, what if it's compounded continuously? How can we put that into the equation? Well, how many times per year is that? Well, that becomes our infinite number of times. So we have a different equation that we can follow that's really similar to what we looked at before. So here we have A equals, and I'm using my different colors again just so I can keep things straight in my mind, P times E, here's this letter and number that we're dealing with, to the R, and my last one right here, T. So using my colors, I can help us figure out as well. So T is our time in years, right? R is always going to be my interest rate. Again, as a decimal, we can't use the percentage. We have to turn it into a decimal first. And then E is a number. E is not a letter here. And P is, again, our principal, our starting amount. So if ever you have a problem that asks you, okay, so now we're compounding this interest, but we're doing it continuously, this is the equation that we're going to use. We can also use this equation to figure out things like the interest rate if we know it's been compounded continuously. So use this to plug in the things you know. Just keep in mind and remember that this is a number. It is not a letter. It does not represent anything else besides the actual number E. And your calculator and Desmos will know that E is a number and not a letter. So really that's it for 6.2. We just looked at one page of stuff. So we're going to take these graphs and we're going to change our A and our R and see what happens to it. How does it change my graph? And then we're really just going to be looking at some continuously compounded interest. So now is the time where you need to go ahead and log in and get working on that homework. And please contact me when you get stuck.